In the last lesson, the last assignment, there was an example in the video that I made that showed how to factor a quadratic in standard form when the a part was not equal to 1. Just a reminder, quadratics in standard form look like ax squared plus bx plus c. So there's a number out in front of the x squared, a number in front of the x, and then a number all by itself. By the way, the c could be 0, and the b could be 0. But if it's a quadratic, the a will never be 0. Anyways, these guys are really simple to factor when a equals 1 because the a just goes away. We can just say goodbye to it. Unfortunately, right now, we cannot say goodbye to it because we're looking at quadratics where the a does not equal 1. Anyways, in the last video for the last assignment, I showed you how to factor when you have a number in front of the x squared. This is a special case where the number in front of the x squared is actually the greatest common factor in the whole quadratic expression. So we're going to go ahead and if the number in front of the x squared is the GCF, is the greatest common factor, in other words, 7's a factor of 7, and 67 is a factor of 63, and 7 is a factor of 140. If that's the case, if 7 is a factor of all three of these numbers, or if a number is a factor of all three of these guys, a, b, and c, then we can just factor it out, and you can use the method for factoring is simpler. So let's take a look. So I'm going to go ahead and take the 7 out. And if you don't mind, I'm going to skip the b's because they look like 6's when I write them. So I'm just going to write it as x squared for now. And then minus, if I divide a 7 out of 63, what do you think I get? This is where knowing your multiplication tables really comes in handy. The answer should be 9. So it'll be x squared minus 9x. And what if I divide 7 out of 140? What do you think I'll get? That one's a little bit beyond the standard multiplication tables, but 7 goes into 14 twice. And then if you 14 is times 10, so it looks like if I divide 7 out of 140, I should get 20. So I'm going to go ahead and put plus 20. And now, by factoring out the GCF, I made it much simpler to factor this other part. We're going to go ahead and use this x method. And what we do is we take the number in front of the x squared and this last number, the number all by itself, multiply them together, put them on top. In the case where the a is 1, it's just 1 times 20. Then we take the number in the middle, put it down below, that's negative 9. The number down below will be the sum. Let me go ahead and write that. This guy will be we'll do that in purple. This guy will be the sum of whatever numbers we put here. And this guy up top will be the product of whatever two numbers we put here and here. Okay, so we got to find two numbers that add up to, well, that multiply together to get us 20 and that add up to negative 9. So the way we're going to do that is we're going to make a list of all of our factor pairs of 20. Always start with this number on top, make a list of the pairs of factors for that number. Then we're going to go ahead and say, well, 1 times 20 is a pair of factors. 20 minus 1 is not 9, though, so I can't use that. 2 and 10 is a pair of factors. 2 times 10 is 20. 10 minus 2 is 8. We're close, but no cigar. Let's see here. We could try 4 and 5. That's definitely 20. Ooh. Now that's looking pretty good. 4 plus 5 is 9. It's still not exactly what I want because 4 plus 5 is positive 9, and I need a negative 9. So if I do negative 4 and negative 5, then I get negative 9. And then I have to check, does this times this also equal positive 20? And it turns out it does, so we're in pretty good shape. Okay, now, what we're going to do next is we're going to use the negative 4 and the negative 5 to get the factors for all of this stuff, okay, for these guys right there. So let's go ahead and get the factors for that trinomial. They'll be binomial factors. It'll be x minus 4 it's a binomial because it's two things that are added or subtracted together. And then x minus 5, again, it's a binomial because two things that are added or subtracted. And then when I multiply those two guys together, each one of them is a factor of this trinomial, 3 terms, 1, 2, 3. And the only thing is, don't forget, we still have to multiply everything times 7 in order to make this down here a direct substitution for this. So I'm just going to circle those just to make sure we're real clear. If I'm trying to find a new way to write this, well, then I need the 7 in there, okay? The 7 is part of my new way of writing this. Okay, let me go ahead and get rid of that so that you guys have a nice clean picture. This is a completely factored trinomial. All the parts are needed, and so maybe I'll go back and I'll go ahead and box this and say this is my final answer for this particular problem. Again, notice I didn't have to do all the fancy stuff from the last lesson because I was able to factor out the GCF. Okay.